Hi everyone, in this second Weblab we will discuss the environmental impacts of food service and the food supply chain. The Weblab is divided into two parts. The first introduces the main environmental impacts of food service and food supply chain. The second presents examples of good practices that can be implemented by stakeholders in this supply chain. To understand the main impacts of the agri-food supply chain, we are going to introduce the concept of the food system. This concept goes beyond the idea of a linear food supply chain that connects the 5 phases from field to fork: production, processing, distribution, food service, and consumption, and also includes the transport logistics that connect these phases, the energy use for each of them, and the interconnection of the food supply chain with the biophysical environment and its constituent natural elements, as well as with the socio-technical environment. A very simple example is food waste. 43% of waste occurs at the household level, partially due to a shift in the consumption patterns, richer and therefore less careful, but also to the loss of certain traditions, such as the so-called leftovers recipes. The main impacts of the food system primarily concern greenhouse gas emissions. In fact, food systems are responsible for 30% of anthropogenic CO2 emissions. Of this, 10% is caused by agriculture alone. Meat and dairy production, on the other hand, is responsible for 79% of greenhouse gas emissions. Here too, we can understand the relationship between environmental impacts and social and cultural models. For example, a shift toward healthier diets with a reduced consumption of animal protein, often replaced with plant-based protein, would automatically lead to a reduction in greenhouse gases. Furthermore, agriculture is responsible for 75% of nitrous oxide emissions, 300 times more powerful than CO2, and 94% of ammonia emissions. Another impact of the agri-food supply chain is the so-called food miles, or the number of kilometers a food product must travel from field to fork. An average meal must travel approximately 1,900 kilometers before reaching our table, 48% of which is attributable to the consumer, with consequences for product freshness, resource use, climate-altering emissions, and food waste. Another impact of the food system, based on the current agro-industrial model, is soil degradation and loss. Industrial agriculture and the use of pesticides cause a reduction in organic matter, erosion, compaction, deforestation, and waterproofing, which, in extreme cases, leads to flood risk by increasing the speed of water flow over surfaces, and furthermore, salinization, water contamination, and desertification. Another phenomenon is the degradation and loss of agricultural landscapes, for example, through monocultures with the resulting loss of rural identity. All these phenomena cause the loss of 170 million tons of soil in Europe every year. Furthermore, cultivated land is subject to an erosion rate of 3.24 tons per hectare, approximately 78.3% of total soil loss, unlike forested areas where less than 1% of erosion occurs. Furthermore, 8% of agricultural soils in Europe contain pesticides, primarily glyphosate and derivatives, DDT, and fungicide, with consequent negative impacts on the environment and human health. Industrial agriculture also significantly impacts natural resources. In Italy, for example, total water consumption is 26 billion cubic meters per year, 43% of which is accounted by the agriculture sector, which only marginally relies on the water supply network. Finally, the environmental impacts of our supply chain is the loss of biodiversity, identified as one of the most significant factors for the survival of our planet. Agriculture alone threatens approximately 86% of species at risk of extinction. It is also important to remember that of 6,000 species and plants cultivated for food, only 200 contribute significantly to the food we eat, and of these, only 9 account for the 66% of total production. Furthermore, nearly a third of fish stocks are overexploited and 60% have reached or exceeded the point of no return. The loss of biodiversity also has a huge negative economic impact, as demonstrated by the European Environmental Agency annual assessment of ecosystem services lost, which stands at around 50 billion annually and is expected to reach 13 trillion by 2050. Another element of the food system with a significant environmental impact is waste. In Italy, for example, more than 5 million tons of food are lost along the supply chain. Of these, 43% is lost to end consumer, while 57% occurs in the first part of the supply chain. In 2020, approximately 27 kilograms of food per capita ended up in the garbage. In terms of costs, food waste in Italy causes a loss of 6.4 billion euros per year, which rises to 10 billion if losses in agricultural production, the food industry, and distribution are considered. Another negative impact of the food industry concerns the production of packaging waste. In Europe, 78 million tons of waste were produced in 2018 from packaging alone, approximately 174 kilograms per capita, and full 13 kilograms more than 10 years earlier. In Italy, the per capita share is approximately 211 kilograms, above the European average, with the majority, 41%, coming from paper and cardboard packaging. On average, each Italian citizen produces 1 kilogram of plastic every 5 days, and 73 kilograms per year. So, how can we prevent the negative environmental impacts we've mentioned? An initial list of practices involves reducing food miles and improving environmental quality through production choice. For example, by using local zero-mile products or promoting the purchases of organic products grown without the use of pesticides. In this regard, the European Commission's Farm to Fork strategy has set the goal of dedicating 25% of agricultural land to organic farming by 2030. Specific criteria, such as those of the Marine Stewardship Council, have been developed for organic aquaculture and organic fish production. Another good practice could be to promote the production and consumption of quality products and native species. For the restaurant industry, carefully selecting suppliers with environmental certification for their products can be helpful. Finally, considering the gas emissions associated with meat production, promoting the consumption of plant-based dishes is helpful. Other good practices are related to reducing food waste. Initiatives that businesses can implement to prevent food waste include, for example, streamlining purchasing and ordering and improving logistics in warehouse and transportation management. Another initiative on the consumer side aimed at reducing waste is the possibility of using doggy bags following the generation of surplus food. Other good practices include adopting smart recipe aimed at consuming products close to their expiration date, adopting technologies to extend the shelf life of products, monitoring food waste, and any other initiative aimed at raising awareness of these issues. Regarding the recovery and transformation of surplus food, a viable, logical, and ethical solution involves charitable donation, such as food banks operating nationwide to redistribute surplus food. Another initiative to reduce food waste involves transformation. For example, in Italy, the social warehouse of Potenza, Basilicata, through collaboration with a local brewery, have created a beer, Birra 166, from stale bread scraps. In Lucca, Tuscany, fruit juices and tomato puree are made from damaged yet perfectly intact food products that are unsellable. Digital applications such as Too Good To Go are also mentioned for the redistribution of expired products, such as compost production, animal feed conversion, and, ultimately, the efficient collection of organic waste to ensure its appropriate reuse. Regarding packaging, reduction can be achieved through numerous practices, such as using delivery containers made of recycled or reusable materials, purchasing loose food products, minimizing the use of single-serving containers, and using containers made of sustainable materials for home and restaurant use, unless the use of disposable products is supported by documented technical requirements. Energy reduction practices refer to appliance label with a high energy class, subject to periodic inspection and maintenance. Some very simple work practices involve reducing defrosting or integrating refrigeration with the HVAC system. Furthermore, for example, the use of natural refrigerants in grocery store or using self-off lighting or occupancy-sensitive lighting system. Finally, regarding water resources, using efficient appliance and optimizing kitchen operations to reduce water consumption are easy to implement and useful solutions. Thank you for your attention and see you at the next and final Weblab.